Hello, hello. Long time no see. My favorite community of vibe coders and AI developers. Today I am Anton and my friend Baruch. Hello, Baruch. With
Hey, hey,
with
Anton.
you,
Hello,
with
everybody.
you, and we are going to discuss all kind of different things today, like how to guide the agents to generate the code for us, and maybe we will learn something. Baru has an opinion on that, and he has a presentation on it. Hashtag I have a presentation on it, or how like you say it. You say it like you tell us what's the official hashtag that you use for referring at your talks.
Yeah, I have a presentation about that. That's the official
Perfect.
hashtag.
And I actually wanted to get a glimpse of what is going on in our Discord. And there are different channels. There is the general chat where people discuss various things, and there are feature requests. Of course, people want to have some features that they don't have in Junie yet, but like are eager to have. There is a this just for fun thing where people post different funny stories and memes and so on. But most importantly, for these live streams, we have a dedicated channel where people can suggest a topic. So there has been some suggestions, and it seems like not even in this channel right here, but also here, but in overall, like in Twitter, in different public discussion channels, Telegram, uh, like in different channels on Discord as well. People talk about guidelines and how they can how can they guide the agent to do what they want. So I thought it would be nice to maybe take some task and try to mm, do something and experiment with guidelines. But I know that you have something in your presentation about this, about general principles and how we can guide those agents, right?
Absolutely. That's exactly what the presentation is about. How can we make what agent generates a little bit more predictable and controllable using guidelines, among other things?
Perfect. So this will be our main focus today. But before we start, I want to bring up another channel that we have, what we have done. Basically, this is the channel where people publish something that they have achieved with like with Junie or building something with AI. One of the latest achievements here, the general posted that he was building an app using Kotlin and Compose for facial recognition. That's a cool project. Very nice. I'm keen to see how it turns out. And there is more, of course. So, folks, if you are building something and you want to share with the community, feel free to post here on this channel. And I think without further ado, we can switch to your screen and talk a little bit of theory.
All right. Okay, let's do it. So, just to give you a little bit of context, this is a keynote from an amazing conference called the GeekOn that we both attended last week. Unfortunately, we didn't meet because you had to leave early and I arrived late, but we were there in the same conference. And me and another colleague of mine called Leonid Igolnik, who is a very senior engineering leader that has more than 25 years of experience, delivered the keynote called Back to the Future of Software: How to Survive the AI Apocalypse with Tests, Prompts, and Specs. It was a very fun presentations. We were in costumes of Mark and Doc and Marty from Back to the Future movie. That's why the general visual style is Back to the Future. So for those of you who weren't there, you have a great opportunity to get this keynote now. Unfortunately, Leonid is not with us, but I will try to represent him as much as possible. The reason why I want to show you this presentation is because the idea of the prompts, the specs, and the tests is all about guiding our AI towards doing the right thing, by using Junie guidelines and more other things. And once we get the theory, once we are through the idea of intent integrity chain and prompt driven development that we are going to talk about, we will actually see if this thing really works. We will open IntelliJ with Junie, and we'll give it a try. How that sounds?
Perfect. That's what we want to see.
All right. So let's start with something that you might notice and take it either like with the grain of salt or not. And the idea that we all as developers are going to be replaced with AI. You probably heard the news about Microsoft that on 1 week claiming that they already replaced, that AI already writes 30% of their code. And you might think about it as a nice gimmick to promote their AI, obviously the Copilot, but also the week later you hear about pretty brutal layoffs. 2,000 developers were actually laid off from Microsoft, and you might wonder if those things are related, and if really 30% that the code is written might be responsible for those layoffs. And you hear the similar news from other conferences as well. Grim, Grime Reaper AI. Hundreds of jobs at IBM and CrowdStrike vanish as artificial intelligence makes human more dispensable. And there are other news. Goldman Sachs, for example, predicts that AI could replace 300 million jobs. And while they're talking about all the jobs out there, including probably some of the doctors and the paralegals and who's not, a big time of that are developers as well. And it's a pretty natural panic, and this is something that we also saw previously with other hype. Couple of kind of comparing ideas from years ago. So I will never trust code that I didn't write myself. Sounds very defensive for the current hype of AI, but something that we will hear today. But this is actually something that Grace Hopper heard in the 50s when she introduced Fortran and a compiler for the first time. And it's fascinating how 70 years later it's absolutely the same argument that stands between us and code generated for AI, that was 70 years ago when it was the compiler that first kind of interpreted machine code. And the other way around, you might remember this quote from the 90s, falsely attributed to Bill Gates, how 640 kilobytes of memory ought to be enough for anybody. And we hear exactly the same argument today when we talk about a context window and how large it should be and what should be enough. In the end of the day, we've seen this panic before many times. It was when a compiler assembly was replaced with compilers, or when the procedural programming languages were replaced with object oriented, when virtual machines replaced bare metal and local execution was replaced by the cloud. And now it looks like it's also very similar replacement or very similar hype.
I have
What?
to add to that. Um,
Huh?
I have to add to
Yeah,
that.
yeah.
Like when you hear this argument that I will never trust the code that wasn't written by me, what about outsourcing? What about your colleagues? What about delegating the task to a junior developer? I mean, it's kind of the
This
same.
This is excellent comparison. And I think there are very important differences between delegating your code to your colleagues, either junior developers or outsource out there, and trusting AI. The difference is that you expect competency and integrity from people, and you don't expect it from AI. For example, you expect a base level of understanding what people are doing. Even when you delegate it to someone more junior, you still expect that they have some kind of a relevant knowledge. And most importantly, the integrity part, you expect them to tell you when they need help instead of just cutting corners and maybe doing like writing tests that will reflect wrong code just to hide the fact that they did something wrong. So this is the biggest difference between delegating to other humans than to delegating with AI. Delegating to AI has inherently less trust, and we're going to get to it in a minute. It looks like they all those changes have a pattern, and the pattern is the level of abstraction is raising with every new iteration. We're talking about going from machine code to human text right now. If we look at all the range from the assembly and the machine code to prompt, and this is a fascinating trend that builds up new level of abstraction every time. And as we just spoke, this level of abstraction is actually different. This time, our fear is actually have a good reason. And the reason is that you cannot trust AI to do the right thing. And the typo here on this slide is not accidental. This is actually AI which generated this slide, and I as a demonstration I left the text as it was produced, and you can see that we really cannot trust it. The problem with AI is that it is a stochastic model. Stochastic model assumes that non-deterministic results are not a bug, but a feature. And you can see here how exactly the same prompt, the quick brown fox jumps, generates different results every time. And this is again by design. There is a thing that is called temperature in the model, and basically the higher the temperature of the model, it goes from 0 to 100. The higher the temperature in the model, the most creative the model gets. Basically, the higher the temperature, the more hallucinations you will get. The interesting part here is that you cannot say, you know what, we have a great solution, let's lower the temperature and then we will be protected from hallucinations. Because if you lower the temperature, the model becomes unusable. It will stop being creative. It means that it will stop finding not trivial relations between objects, between vectors. And the whole idea of a neural network and the answers that we get is that it manages to find relationships between similar concepts, but they are slightly different. Only by having temperature higher than 0, the model can say, you know what, a king relates to a queen, but it also relates to a man. Those are not exactly the same things. And when we raise the temperature, we allow those variations to get in and to provide us with the smartness of the model. So we definitely need to raise the temperature to some level. And obviously, the more we raise it, the more hallucinations we get. There is it's a trade-off, and there is like a nice play here on which temperature to choose. But what's important for our cause to remember is that stochastic systems by default not deterministic, and you will for sure get different results. Now, this reminds me of an old saying about an infinite number of monkeys with an infinite number of typewriters that will eventually generate Shakespeare. This is exactly what AI models are. The only difference is two differences. We gave them we gave them GPUs instead of typewriters, and they are less random than monkeys. They are definitely nudged towards plausibility much more than in randomness, but and this is why they overperform randomness, but they are still fundamentally non-deterministic. You cannot trust the monkey to write the production system. And yet, this is what we see with vibe coding. Vibe coding is essentially let monkeys write your production systems and hope that everything will be okay. So this is me, Baruch Sadogursky. I'm J Baruch at everywhere, and you can follow me. You can also see like it's in my lower third. I'm a head of developer relations in a company called TaxCare. We do endless life support for programming packages, Java and others. And obviously, I'm very into new levels of abstraction. I'm abstraction connoisseur, and with 25 years of experience in IT, I saw a lot of those hype waves happen, and this one is particularly interesting because I truly believe it is different. I started with development as a Java developer, switched to DevOps with a great company called JFrog that you are all probably familiar with, and now doing all kind of stuff that related to developer productivity in TaxCare, including the intent integrity chain that we are going to talk about today. I'm a Java champion, co-author of a couple of books, DevOps tools for Java developers and the Liquid software about the future of software release. And the most important slide of this presentation is this one. If you go to speaking.jbaruch with the smart dot between the U and the C, thanks to Switzerland top level domain, you will find the slides that are already there. The video of this talk recorded from Geekon with Leonid Igolnik, and all the links for everything that we're talking about right there. It's in the bottom of every slide. I'm not sure how visible it is because I think my face is on top of that. But here, Anton can show it to you. So anyway, I will manage it in the end that you will be able to go there whenever. This is not relevant. Sorry about that. All right. Okay. So we know that AI generated code is not great. Not only we know that, we now have a very significant amount of research that actually proves that. Here's an example, a comparison between GitHub Copilot, Amazon Code Whisperer, and ChatGPT, and respectively 65, 46, and 31% of the code generated by those models was plain wrong. More so, it's not just wrong, it's actually dangerous. 40% of the code generated by AI by GitHub Copilot actually have security vulnerabilities in them. There is an entire new section of supply chain attack that is made available by vibe coding. A model hallucinates with a package that does not exist, and people squat this name on npm registry, upload a malicious package there, and then suddenly this package will be executed when a model hallucinated and used this package. This is pretty scary. And obviously asking a model to fix what it did wrong is as reliable as everything else. And the problem is self-verification. So this thing, the self-verification, is exactly the problem with the monkeys. We're going to get to that. It looks like we invented an inverse Mr. Fusion machine. If you remember the movie, Mr. Fusion was garbage in, energy out. Inverse Mr. Fusion that we have now with LLMs is energy in and garbage out. Energy in more than one term. Energy that we put into wrangling the monkeys to do the right thing, and energy as all the data centers that the models are running. So yeah, the panic is absolutely justifiable, I think, because it's really, really scary. But where there is a panic, there is also an opportunity that we're going to talk about. And we see AI not just in our industry. So, AI assistant has wormed their way into about basically almost every profession. Paralegals draft their briefs with AI, and then obviously got slapped on the hand when they present in court non-existing precedents and this kind of stuff. Radiologists trash scans using vision bots, and sales reps rely on AI to parse their discovery calls and what's not. Now, what's interesting is that there are two patterns that emerge in every industry. There are people and professions that use AI very, very efficiently. And then there are terrible stories that we hear how everything went wrong when someone relied on AI too much. And the interesting difference is in the user. The key moment here is whether the users understand the system that they are working with. And this is critical. Without expertise, we get chaos instead of something that is working. And the difference between an expert using AI and generating something profound and a junior using AI and generating garbage is easily explainable by the example I want to give you. So imagine we have a JSON parser, and this JSON parser is a little bit slow. And then we ask Junie to make this parser faster. And what AI does, it removes JSON validation block. It is faster, but probably it's not exactly what we wanted to do. And this is where Anthony should say, but hey, it will probably be caught by tests because we obviously have tests that check the validation. But the problem is that AI will make sure that the tests pass by removing the irrelevant tests of the validation, because we removed the validation block that was slow. And obviously, we deleted all the tests that were related to that because we don't need it anymore.
Or just
And
add the
this,
ignore annotation there, and the test will be ignored.
of course, and this is what we mentioned as circular verification, because in the end of the day, AI will do the right thing as AI understands it. And this is a problem we need to solve. Now, from the AI perspective, it didn't do anything bad. It wasn't malicious. It is something about much more relatable. A developer who thought they're asking one thing, but actually asking another thing. The author didn't want AI to remove validation, obviously. They wanted to make the endpoint more performant. But the prompt never said that. The prompt left out what should never be changed. And AI, like a diligent intern or a junior developer with no context, followed the instructions exactly. It did what it was told, but wasn't what the intent. And you might say, okay, I understand how junior developer can miss it. I understand how junior developer might not be as experienced to give instructions, but experts and seniors shouldn't probably have this problem. The interesting thing is that they most definitely have. The problem of explaining what seems to be obvious to us, or not explaining what seems to be obvious to us, known as the curse of knowledge. It's a psychology phenomenon that us that basically states that whatever seems obvious to us, we assume that it stays obvious to everybody else. And we see it a lot in the conference talks and other presentations when important pieces of information are omitted because the author or the presenter assumes that everybody knows that just because they know it. It doesn't happen a lot in our day-to-day life because we speak mostly with our peers and colleagues, and even if their level different from others, they might be more senior or more junior, we are still in a large scheme of things in the same context. So omitting trivial stuff will probably be okay. In our example, even if we speak with junior developer, with an intern, with a fresh grad, telling them, hey, make the endpoint faster, we still assume that they will know that they shouldn't remove validation. It's just common sense. And but when speaking with AI, the curse of knowledge hits super hard because AI don't have this context, never had, never will. The idea that validation is something that should be kept is absolutely nowhere to come from. So the curse of knowledge now is much more profound, and it's actually a problem for all of us. And this creates what we call the intent to prompt chasm. This is the disconnect, the space between what you wanted and what you asked. And this is critical in our ability to interact with AI because with that, once you see this chasm, you cannot unsee it. It is the moment when the AI output exactly what you typed and you realize it's not at all what you asked. To overcome the intent to prosm chasm, there are a couple of very important traits that all of us should possess. The first is a deep domain mastery. And this is the profound practical knowledge about architecture, performance bottlenecks, security vulnerabilities, dependency pitfalls, and edge cases accumulated over thousands of builds, deployment, and outages that we as experts all live through. And this is one of the most important differentiators between developers who use AI potently and vibe coders that decided that they don't need to know code in order to write an application. And I think all of us witnessed this example a couple of months ago that was very viral on X and other social networks about a guy who was very proud of creating some marketing SaaS application, not knowing anything about software development, and declared that developers are completely obsolete. He had some interesting success, some customers that actually start to pay him just for a couple of weeks after his application crashed in flames, and he had to actually close the entire thing and refund people their money and what's not. What he really missed is exactly that. He thought that if the application just works, it's probably fine, but there were obviously security vulnerabilities and performance considerations that he didn't consider, and all that backfired dramatically just on a course of a couple of weeks. Another aspect of this deep expertise is what we call structured imagination. Structured imagination is creative but disciplined skill of anticipating how things can go wrong. Not only when working with AI, but especially one valuable when working with AI. It's the ability of experienced engineers to foresee how an unbound prompt could backfire, how a model can bypass a safety check, or how a vague requirement can lead to unpredicted behavior, as our example with the JSON optimization. And obviously, when you have the domain mastery and you work with the structured imagination to foresee the possible future failures, the way you protect yourself and AI against those possible failures are guardrails. And guardrails is exactly what we need to do in order to make sure that AI does exactly what we need. The challenge is that to define those guardrails, you need to master what we call the art of possible, and those are those three pillars of domain mastery, structured imagination, and uh, purposeful guardrails. This is what you need to have in order to be able to tame the monkeys that are running amok in our code. So, Anton, let me ask you, when you hear about guardrails, what first that comes to mind in order of how do we protect our code from things that might go wrong?
No, you have it on the slide. There is a test.
Exactly. Perfect. Tests is something that any of us as developers completely get. This is our guardrails. Once we have tests, we make sure that the code will do exactly what we need. And obviously, in order for a code to do what test expects, the test need to exist upfront. How do we call it?
Test-driven development.
Exactly. Test-driven development is, I think by now, like a 20 years old discipline that describes the tests before we write code. And today, we might look at it in a completely new light. We can say, you know what? Writing the test up front is almost like expressing our intent in tests. This is how we close the gap between the prompt and the intent, because now the intent is actually code that we can all read and decide whether this is what we wanted or not. The problem is that test-driven development didn't really catch up. And it really didn't really catch up because developers are biased for action. We became developers in order to create stuff. We write code and we have something that is working. And this is the dopamine shot that all of us developers are actually living off. Writing the tests before writing the code is very counterintuitive to our development mindset of, hey, let's just go ahead and write code. The good news are that AI can help. AI can generate tests for us that will make sure that our code is covered with tests, and it can be together with a code. So when we are not letting AI to write our code and coding ourselves, we can at least ask AI to generate the test for us. And this is very important. This is also like a discipline that becomes a side effect. And generally, regardless of who writes the tests, and we are going to get to it in a second, what is most important is that TDD is not just the good practice in the age of AI. TDD becomes the first link in our verification chain that will make sure that what we asked, what we intended to ask, is exactly what we end up getting in the code in the end of the day. We call this chain the intent integrity chain, as you can see here in the hash code in the bottom of the screen, and TDD is the first link towards it. Now, we spoke about how we can put or express our intent in tests and then look at it and realize if that's exactly what we wanted. The problem is that test is code, and a lot of stakeholders in the decision of what product should do cannot read code. Product managers, oh, there is another typo here, and business people cannot read tests. And that means that if we want them to look at the test and tell us, yes, that's what we wanted, we cannot do it efficiently with tests. What's the solution? How about we describe tests in plain English or any other language? Does this look familiar?
Someone mentioned BDD in the chat.
Perfect timing. Here we go. What if we describe the intended behavior in almost plain English? A construct of given, when, and then is human readable. And if it means that it's human readable, it means that the product managers and the business people and the other stakeholders can actually express their intent in almost plain language. BDD is also like, I don't know, maybe 10 years old or even more. And it's also didn't really catch up and or pick up. And the reason why it didn't really pick up is because it's still not exactly plain English. It requires discipline, it requires rigid syntax. And if we will ask product managers and business development people to write those specs, it probably they will probably abandon it very, very fast, because product managers and business people don't want to be constrained by their syntax. They want to express their intent in plain English. Software definition documents are in plain English. Product descriptions are in plain English. This is not. And when they don't participate, developers are still asking the same problem, the same question as we did with test first. Why are we doing it? It's a lot of overhead and it's a lot of ceremony for something that is completely unclear why, if we can just go ahead and write tests. It looks like now it's even worse for those specs. Who needs the specs when we can just vibe code, when we can express our intent in absolutely unconstrained plain English? We can write prompts in haiku and they will maybe work. So Gherkin, just for the reference, for those of you who don't know, curse of knowledge, is the official language of the spec. The given when then, this structure called Gherkin spec, and this is why it's here. So basically, what it looks like that BDD, which didn't take over to begin with, now has even less meaning. But before we discard the specs in the trash bin, let's look at them again. One of the most fascinating abilities of the rigidly structured spec is that it's readable by humans, but executable or parsable by the machines. A machine can take this spec and create a test out of it, which will be a test for our test driven development. And this is where we have the entire chain in place. Prompt becomes a spec, becomes a test, becomes code. So we have test driven development in the picture, we have behavioral driven development in the picture, and a new discipline, which is PDD, and as you might get, stands for prompt driven development. And by using this chain, we can guarantee that what we asked is exactly what we get. Let's look at it in detail. So humans write prompt, and humans write prompt in plain English. That will be all of us sitting together, the developers with the product managers, with the business people, with the customers, focus groups, whoever. We can bring everybody to the table because we are writing plain English. Monkeys generate spec out of our prompt. We ask AI to generate spec based on the prompt with all those given, when, then clauses. Once the spec is written, machines generate the tests out of this spec. And when I say machines, I mean deterministic algorithms. Because the format of the spec is rigid and machine parsable, we can ask tools like Cucumber to go ahead and generate JUnit tests out of Gherkin specs. There is zero magic involved. There are no monkeys. The tests are generated by a reliable 20 years old technology that actually works. Once we have the tests, we can start writing code using test driven development because the tests are already written, and we can be sure that whatever implements those tests is exactly what we asked to begin with. Now, there are two places or three places in which we might have a problem. You can see here that monkeys generate a spec and monkeys write code. And you know what is the most important rule of working with AI? Never trust a monkey. Why? Because they are not deterministic systems that just trying to guess what will be the right thing, and it is not always works. Most of the time it doesn't. So we cannot really trust monkeys to do exactly what we need. So let's see what parts of the chain have this problem. Prompt is created by humans. It's not relevant if we can trust it or not, because this is the prompt that humans actually wrote. So it is what it is. Spec is generated by monkeys. And as we just said, what is generated by monkeys cannot be even trusted. Test is generated by monkeys from the spec, cannot be even trusted. And this is where we can solve it. The way we solve it is by not letting the monkeys generate the spec. Instead, we generate it with Cucumber, with deterministic test generation, and monkeys are not the part of the game. So once tests are created by deterministic algorithms, now we can actually trust the tests. The last part, code, is generated by monkeys as well. What does it mean? Exactly, it cannot be trusted. The good news are that we have tests that will make sure that our code is passed. The only thing that we need to do is make sure that monkeys cannot touch the tests. This can be done by making tests read only on the operating system level or by special prompts and guidelines that will force monkeys not to touch those files. Whatever way we do it, once the tests are immutable and locked, we can actually make sure that whatever monkeys generate eventually, as with Shakespeare, will be exactly what we need. It will run the tests until the tests are passed, and we will make sure that it actually works. So let's see how the entire validation works. So prompt, validation not required. Spec is generated by monkeys. But since the spec is readable, it's very easy for us, the humans, to actually validate what monkeys have done. We will go through the spec, we will read through the spec, and we will say, yes, this is correct. This scenario is completely hallucinated. We didn't ask that. And maybe we'll say, you know what, there is a scenario that is omitted, and we need to go back and generate it. But generally, the ability of humans to read the specs is what guarantees that this monkeys that generated the spec did the right thing. Tests are test generation is completely safe. Once we approve the specs, we will generate the test using deterministic algorithms. We don't have a problem with generating tests. And then code is generated by monkeys, but validated with our tests. It will be our test runner that we will make sure that whatever end result with actually passes the tests. And once the test is locked, we're actually in a very good place to rely on it. So what we have here is an executable shared understanding. And this is profound, new, and really exciting because now we can make sure that only what's in spec gets to the tests and only what passes the tests stay in the code. How that sounds, Anton?
That's an interesting idea.
What if I tell you that this is not only idea? We can actually write code with intent integrity chain today in IntelliJ using Junie.
Let's try it.
Let's try it. All right, let's see if that actually works. So I have a demo from the talk, but we are going to do another demo now live. What I want to show you, and that's the only file that I will carry over to our new project, is the guidelines. Now, the guidelines are the core of the integrity chain implementation. This is where we tell Junie to follow this process. So you can see here the intent integrity check rules, and let's go through it. So we have the description of the persona, and we describe them as a very senior developer that should follow the rules with precision. This is very important. Complete these phases fully before proceeding, and this kind of stuff. Then we describe how it should work. For example, the version control. Version control is critical for intent integrity chain because we need to make sure that what we see is done exactly as we see it, and we can have fallback to whatever needed when needed. Phase transition requirements, phase structure, etc., documentation requirements that we will see what it is doing, etc. And then here is the development process. The analysis phase is the first step of making sure we close the prompt to intent chasm. It gets our prompt and it breaks it down to a set of documents that we as humans can review and decide if that works for us or not, and then iterate through it until we are sure that our intent improbably captured. Once this is done, we can start generating test specs. And test specs will be in exactly the Gherkin behavioral driven development format, right? It will write feature files that will include those given when then clauses that again we will review. We have a gate that will stop, and user approval will be required to move forward and to get to the next step. This is where we verify that the work that is done is actually done properly by the monkeys. And here is the test generation case. Now, during this demo, I notice a glaring omission in our instructions, and we're going to fix it right now and see if that helps. Nowhere in the test generation case it is said that we should use a non-deterministic tools to generate our requirements. Let's fix it. The way that we're going to fix it is by using Junie. I'm going to, first of all, you know what? Let's start with opening a new project. And this is going to be Junie stream demo project. It's Gradle, it's Kotlin, and this is fine. Okay. So the first thing we need to do is create the guidelines file. So as we know, we're going to create it in dot Junie guidelines
By the way,
md.
you can create the guidelines by clicking the plus button there.
Ah.
No. In the chat, like in the Junie panel. Yeah,
Here we
and
go.
there
Today I
is
learned.
create project
Perfect.
guidelines. Yes,
Excellent. This is just great. Okay.
and it gives you
So
the
we're going.
template with the like sample text, but it's for you to replace.
Excellent. All right. So we're going to replace it with our stuff. Now let's have some fun with Junie. Analyze the analyze. By the way, typos don't matter for LLMs because one of the benefits of them being scholastic systems, they find similarities. So if this word is close enough to the word that I really wanted to use, it's enough for the model to actually work. So analyze the guidelines and uh, clarify that in step 3, and this is our in phase 3,
Hmm.
and this is our phase when we generate the tests.
And are you going to keep the code mode or ask mode?
Code. I wanted to change the guidelines.
Ah, okay.
If it can, we'll see. That phase 3, that in phase 3 is the test generation is performed not by an AI model, but by a deterministic tool like, right? And that's exactly the idea. We don't want AI to generate the tests because we cannot trust the monkeys, and there is no guarantee that the test will comply to the spec. And we also don't have a good way to review it because remember, specs are approved by non-technical people, by product managers and by business stakeholders, and they cannot retest, so they cannot compare the test to the spec. So we have to make sure that monkeys are not going to tamper and output something that we don't want. And for that, sorry, we need deterministic tool to generate our tests. Let's see what it does.
The guidelines. My take on those is that they are not rules but the guidelines, so it means that it's probabilistic. How is it for you? Like,
It's
Good.
you are completely right, and again, it's a problem, but there is also something that we don't have anything like. There is no fix for that. It's probably exists because it's guidelines, not rules. You are absolutely right, but it's better than nothing. This is why some of the stuff, like for example, locking the tests, are better done by system tools and not by guiding the AI not to do it. So yes, we tell them number of times here. Okay, before we go there, let's finish. Let me finish my thought. So we try to force it in the implementation phase not to touch the tests, right? And the words like critical and never modify and all that is our attempt to kind of force the guidelines on the model. But even the presence of those words kind of implies to you that there is something going on here and it won't really be obeyed or will be obeyed 100%. And this is where we can just go and say whatever should be never modified should be actually read only, and we can actually do that by just locking the files on the file system and make them read only. This is how we have to battle this non-deterministic nature of the guidelines as being not being rules. Yeah, let's see what it did. So here what we see here. So this is our task: generate test skeletons from specifications using the deterministic tools like Cucumber. Nice. We'll see how that works. And then another line: must use deterministic tools, not AI models for test generation. Okay. I mean, a developer can hope. We'll see what happens now. Okay, so I think now our guidelines are pretty much exactly. Let's continue reviewing them. So yes, so test generation phase. Now we said that we wanted to be deterministic and would do it with stuff like Cucumber. And here is the process: must generate tests directly from Gherkin, must implement all the scenarios, must maintain clear mapping between tests and specs, and all the stuff that we want to make sure. And once this is done, this is again user approval required. So yes, as I mentioned, here it will be much harder for us to validate the intent because specs were reviewed by non-technical people, but tests only technical people can read. But it's still an important gate for the AI to stop and ask our permission. And once we gave that permission, the next will be the implementation phase and write code to make the test pass, refactor while maintaining test coverage, verify behavior, the directories that it can create or update, and most importantly, as I showed you, the things that it should never touch. Now, during this stop, we are able to go ahead and log the files and make them read only to make sure that it won't touch it. We'll see how that works as well. More working principles like phase integrity, all those are over and over attempts to, back to your point, to force the model to actually follow those guidelines and do exactly what is needed. All right, let's do something fun. What do you have in mind?
Mm. No, let's do a simple example this time, so that we could actually track how those guidelines are,
Mhm.
affecting the results. Maybe the TODO app, or I don't know,
Let's do TODO App. That's a
TODO
good
app.
idea. So here we are, humans prompting the original intent. And that includes the developers, the product managers, the business stakeholders, everybody else. So create a to-do app, a simple to-do app. So it should be no front end because we don't want to complicate things. In memory only. No persistence. Operations like add to list, mark done, remove, delete from list. What else do we need? Yeah, I mean, that's probably should be enough for us to see how that works. And this is us. We brainstormed about what features do we want and what features don't we want. And let's see what happens now. It opens the guidelines, which is already promising. By the way, I could ask it again in the prompt to follow the intent integrity chain protocol. I didn't do it. We'll see if that was enough. I think it was because it actually starts doing what we have in the guidelines. Version control gate, initialize Git repository, configure Git ignore, make initial commit, and the commit is like this is level 0 before we start. And then we will have analysis phase. Look at that. It actually looks like it's doing the right thing. So it did the commit, it tagged it correctly with phase 0 in it, and now so far it's being pretty good with following the instructions and guidelines. Okay, let's look at the docs that it's generating for us. Well, for now it's just a directory.
Yeah. Well,
Oh, here we go.
the
We get some
guideline
docs.
the guideline that you specified that it should use the deterministic tool for generating the tests. Will it call out this tool somehow? How does
We'll see.
how does that work?
I would expect it to add to like Cucumber plugin to our build and run the spec.
Aha. Okay.
We'll see how that works. So we have our product context, and it looks like it does the right thing. Allow user to add tasks, mark tasks done, delete from the list, no hallucination so far. Non-goals, persistence of task, user interface, user authorization. Very cool. It kept the scope very small. And a couple of user stories. As a user, I want to add a task. I want to mark task as done. I want to delete task, view all tasks. Very nice. This is actually pretty much on point from what we expected from a to-do app. There is a system architecture document, and it explains our very simplistic architecture of domain model, repository, and service layer, and then repository pattern, service layer pattern, data flow, error handling, and testing strategy. So far, so good. Technical assumptions. Technical assumptions will be in-memory storage, single users, synchronous operations, very good. Technical decisions, immutable domain model, UUID for task IDs, fine. Exception-based error handling, and limitations. Data lost on restart, very true, it's going to happen. No validation rules, absolutely true. No sorting configurers, no bulk operations. Those are great list of limitations. Future considerations, persistence, multi-layer, API, UI, excellent, great job. And then the last part is active context. And this is where we are in our intent integrity chain journey. Product context, system architecture, and text flow and technical assumptions are all being validated. What will be the next step? And what are going to be done next? Write test verification, define interfaces, document scenarios. Excellent. So, and here we have a problem. It entered the specification phase to create test specifications and defined interfaces without stopping. Now, at the moment, it's not the end of the world because we actually don't need to verify those docs before we see the specs. So actually, we can verify the docs with the specs together. Let's see what happened. We have a contract, which is our interface task, and we have a contract, which is our interface is a task repository, and those definitely will be read only. We also have a to-do service, which also should be a read-only interface. So those are great. We're going to log them and make sure that the code that it generates actually adheres to those interfaces. And we have our features, which is the list of our scenarios. And look, they are human readable. Add a task to to-do list. When I add a task with the description buy groceries, then to-do list should contain one task. And the task description should be buy groceries. And the task with the description should be not marked as done. And obviously, as I mentioned, product managers, business people, and developers, we all go through those scenarios and verify that our intent was perfectly captured in those scenarios, right?
Yeah.
Now, what else was generated? Stuff like the requirements, which now match the everything else, and the test scenarios that are also like a human description of those specs. All right, let's see if it knows to stop now.
Meanwhile,
Because
there is a good comment or a question.
yeah,
So we want to keep the guidelines as small as possible, but add the extensive documentation about the what, if I understand it correctly. So I guess that pretty much summarizes
yeah,
what we have done now.
I guess we can kind of maybe delegate some of the description of the chain from the guidelines directly to some kind of a document that describes the chain. I'm not sure if it has implications on the behavior of the LLM. In the end of the day, it has to parse both. So I don't know if that's something that is really necessary. I know that guidelines are limited by their size, and maybe if we go over, this is where kind of we will delegate to a markdown file that describes the intent integrity chain. Maybe for now, everything in guidelines seem to work. Okay, so here is the problem. You can see here that it actually continued to implement tests. And there are two problems with that. First is it didn't stop to give us the opportunity to review the specs. And the second is it looks like those tests are generated by AI, although we asked those tests to be generated by our deterministic tool like Cucumber. It obviously didn't do that. So you can see that there are tests that are generated probably close enough from the specs, but we have no way to verify it. We don't know that they exactly match the specs. Maybe there are some tests that will be missing. Maybe there are some tests that will exist, although the spec does not exist. Maybe there are some tests that will be purely false. So all that is obviously violation of the steps of the intent integrity chain. So when it will finish, we will ask it to actually go back and revert and follow the steps with the right gates for the input from the user. So just for the experiment, let's keep it running and see what it does. I would predict that it will go all the way to implementation and actually finish everything without stopping even once, which is obviously unacceptable for our goals of implementing intent integrity chain. But let's see what it does. For now, it keeps. Yeah, okay. It committed complete test generation phase, which is wrong on two levels at least. Should have asked us, and it should have used Cucumber. And now I think it will just go into implementation. Let's see what happens now.
Well, if it
Yep.
completes if it completes
Yep.
within one iteration, it means that the task was reasonably small.
Yeah, it actually went ahead and created the source for the folders for our code. And here it is. Here is a task implementation that is actually a real code, which again is completely unacceptable It might be good for a vibe coding kind of observation, like look how great it is, it went ahead and did everything, but it actually defeats the purpose of validation. We didn't validate anything from our validation model, and this is obviously completely unacceptable.
So this
So
basically shows that it didn't really follow the guidelines that we gave it.
exactly. It parsed it. It actually follows the steps, but it ignored completely the part about user input and stopping where it needed to stop. So of course, we'll let it finish again. We used a very here you go. We used a very simple example, so it was completed in one go, but obviously this is completely unacceptable. So let's try to fix it. Okay, now I want to do something interesting. Now I want to interrogate the model to understand why it did what it did. So I'm going to switch to ask mode, and we're going to have a conversation about it. We're going to do a post-mortem. You didn't stop for user confirmation at the gate transitions. This is a clear violation of the intent integrity chain process. Why did you do it?
So you basically make the LLM to self-reflect somehow on the steps that it did, but it probably doesn't have the history of what it actually did.
It looks like it does. I violated the process by not stopping to get explicit approval before proceeding to the rules. Okay, so here, interestingly enough, it actually finds the right places at the guidelines that it violated.
Hmm.
Right, and it's in here and it's emphasized later, and this is okay. It just says that it was a clear violation. Thank you, I know that. In the future I will strictly adhere to the process. Okay, now my question is, I wanted to suggest edits to the guidelines to make sure that it doesn't happen again.
So you want to override the guidelines.
I want to see if there are any interesting hacks that it knows and we don't, that will fortify the idea that it should stop. Okay, let's see. So, what it suggests is a stronger language, and the end of it, frame the engine must present a clear, visually distinct face complete message, and then even force it to have a format. Now, this is interesting because instead of just saying stop and don't do anything, it actually says do something else. And this might be the difference that we actually need, because when it says do something else, it will actually go ahead and will do it. So might be something that we can try now and see if that helps.
This
Add
is
automated, yeah,
very,
add
very familiar with what we did previously when Junie didn't have the ask mode. Remember, if you
yeah,
were asking the question, it was eager to write the code somehow. But
exactly,
if you told it to write whatever you think of doing to the MD file, then it didn't really actually go and develop that thing, but rather write the plan into the MD file.
exactly, right. It's biased for action, exactly as developers. Right, and there are some additions that again stronger language in phase transition informant and other part. You know what? Let's try it. So I switch back to code. Okay, let's see what happens now. And once we do that, we can roll back all the way to the first gate and start from there. This is why it's so important to have the Git integration in the model. Now, this is all the same conversation, right? Because the context in which I interrogated to see what went wrong have to be in the same context of what it just did.
Mm-hmm. Yeah,
Once
makes
we're
sense.
done with that, we can get rid of this context and rely on Git history as a context when we will do a rollback to the correct phase.
I'm curious to see what it changed in the guidelines actually.
Yep, we are going there right now. Okay, it's a commit. Very nice. Here it is. Right. So, well, I don't think it actually did all the changes that it suggested,
No,
which is
it did it in three parts. You see, like there was three edits to the file.
oh, okay, and I see like yeah,
The
well,
if you
yeah.
click on the top, and there was one more above that.
Ah, here you go. Oh, here you go. There is like an entire yeah. No, it did all of it. Yeah, here it is. Approval required. The format. Yep, it actually did all of it. Okay, and there is more here. Yep. Okay, good stuff. Good stuff. All right. So now we can finish with that and we can ask something else. We can say now roll back to the end of what it's gonna be. Where is the first stop? Here, analysis phase. And then once we will approve it, we can actually take it from there and see if what we did helped somehow. It actually knows why we want it, and that's pretty fascinating. The project and the generation phase, which isn't correct, but okay, without proper user approval for analysis phase, it actually realized what the problem is. So we'll see how the rollback will work now.
Okay. Meanwhile, while it's doing, I can give some interesting comments about the operation of Junie. So when you see something that it looks for a file or opens a file or renames a file, and usually there is an icon, like information icon, this little circle next to the action name. It actually refers to the fact that it is using the built-in functionality from the IDE. So that's pretty cool. So the team is integrating the tool even deeper with every release, and I hope they will implement the integration with refactoring actions. That would be cool to see.
Yep. Okay, now we have some very weird state. We don't have tests, but we do have spec, and we have some implementation. Yeah, not great. Use Git to revert. Let's see if we can use that for us. Obviously, we can just do Git revert, but let's see if it can do it for us.
Well, at least it immediately started using Git, not
Yeah. No, I
scanning
would
the whole
expect it.
project.
And by the way, what you just saw was the curse of knowledge. When I said revert, I obviously meant Git. What it hurt is just revert in whatever means possible and try to delete some files and edit some files instead of actually doing Git revert. So for me, it was obvious that the easiest way to revert will be using Git. But for the LLM, it definitely wasn't. And I still think, yeah, here we go. It actually does Git reset. Okay, we have some files here which are not, which shouldn't be, yeah. We can just delete those two for now. I can delete from here. All right, and changes event context. Okay, let's see what's going on now. Now it really cleaned it up, very cool, and we are now really in the right place. So the task to use Git to revert change is successful, and resetting the project to the end of analysis. Context conjure file it correctly indicates where we are. Let's see. Yes, we are in the analysis phase completed, and then we will proceed to specification. Perfect. All right. This is exactly where I want to be. And now again, we could go through it. We already did it. We're actually ready to approve it, but it is important for us to follow the chain. So now, you know what? It looks good to us. Let's say we see, we like what we see, and now we can actually continue. So we can continue in the same context or open a new one. There is no problem in opening a new context because our context is expressed in the guidelines. The intent integrity chain is all the model needs, and obviously our docs. It's all the model needs to continue within a new context window. So
So at this stage, what are we expecting to achieve? What should be our result?
So next step will be generated specs. What I want to see now that it's generated the spec and then stopped for us to approve the spec.
Mhm.
That will be our next step in the chain. If that worked, that means that the suggestions that it made for the guidelines actually work, right?
Mm-hmm.
And obviously, after we approve the spec, the next interesting challenge will be how will it measure, how it will manage to use Cucumber to generate tests. We'll see. Okay, and this is what I said. We're going to have a completely new context. It will have to rediscover the guidelines, read through it, understand what we are doing, understand which step we are, and continue from there.
There is a
Obviously, we
question.
could, yeah.
There is a question in the chat. Have you tried this approach with some existing code base, not from the scratch?
Love it. Love it. Love it. It's a great question. It's a whole different topic, and it's a whole different talk, if you wish, and it's a whole different stream. And this is the reverse intent integrity chain. Now, not only that it works, it has absolutely profound findings. The way it works is that we start to analyze an existing code using AI by covering it with tests. What we do is exactly the opposite of the intent integrity chain. We start from the existing code. When we make it read only, we lock it. And then we make the monkeys to write tests until everything is covered. And by that, I mean not only code coverage, but also mutational analysis, to mutational tests to make sure that the test that it writes actually makes sense. Now, when everything is covered with tests, the next step will be generating the spec from the tests. This is not something we can do non-deterministically because there is no process of inverse behavior-driven development, but we can ask the monkeys to do it for us. And once this is done, we can try and reverse the process, deterministically create tests, and check that they are still really the needed tests for the existing code. And if not, iterate until they are. Now, once we have specs that we know for sure that match the tests and match the read only code, we can actually ask AI to generate the docs that describe those specs and get the system architecture, the technical assumptions, the technical content for an existing code base. And this is absolutely brilliant because it will allow us to dig an intent of some maybe long forgotten legacy project and get it in a form that is, again, humanly readable, that we can iterate through it and move forward. Once we've done that, it's all the system is already set up for intent integrity chain, and we can start evolving the system by adding new modules, adding new microservices, etc., etc.
Um, while you were talking, I think Junie did not follow the guidelines.
Exactly. Yep. It went into service implementation again. We are again not being consistent. Interestingly enough, I did the same demo for the presentation last week, and it did much better work. I'm not sure what happened. Well, we know what happened. Stupid monkey is not deterministic, but I'm not sure if the model changed, because now it's clearly ignoring our guidelines about stopping in the end of. Oh, you know what? I think it reversed the guidelines as well. We run on the
Oh,
same guidelines,
oh,
don't
it
you think?
might. Yeah, it might have happened as well.
Look at that. It's like an empty guidelines file.
Oh, yeah. You did not commit it, right?
I did, but then we reverted everything, remember?
Ah,
This is fun. Thankfully, one of the most useful tools in IntelliJ is local history.
all right.
I just need to, I don't remember where it is.
One of the most requested features is that the local history would have a marker for the
Ah,
AI changed code, and nothing is there. Oh my god.
yeah, no, this is not great. Why nothing is there? This is interesting. Um,
Show local history.
yeah, that's what I did. Nothing there for file. Ah, no, there is. Here
Yeah.
you go.
Oh,
Uh,
there is one. Now we have it there. You see,
what?
whatever you changed, whatever Junie changed is marked with an icon now.
Oh, this is very nice. Look at that. Yeah. Oh, love it. Nice. This is, and it's actually said like Junie text edit. Perfect.
Exactly.
Okay. I think this is our thing, right?
Yeah.
I'm not sure, but let's see if it has like. No, that's not the right one. That's not like the one that it suggested. Ah, no,
Which
here it is. Before
it,
each transition, the engine must run some verification. No, that's not that. Oh, yeah, here it is. Waiting for
it
approval. Yeah, that's the latest version. Perfect. All right. Somehow I can say it to accept it, right? Here
yeah.
you go. This is also should be accepted, and this, and this. Okay. All right. Now it's the right rules. But again, I mean, we probably won't run it again because, it should be another repetition on all this kind of stuff. So obviously our demo failed as it should have been. But I think the idea is clear. There is obviously more work to be done. And don't get me wrong, this is not the end state of the intent integrity chain as I want to see it. There is a lot that can be improved. For example, the idea of stage locks can actually be implemented by the tools themselves. Uh, IntelliJ can help us, for example, lock the tests. and the stop between phases can be implemented mechanically without relying on AI to actually determine it. We have those gates with clear separation, for example, Git commits, and we can easily say after each and every Git commit, just kill the thing, right? Just make it stop, right? And then obviously we don't need to do all those tricks in order to beg to the monkeys to do what we wanted to do. Another thing, the Gherkin specs. We have it today. It's okay, but since we have to express the entire system now and in its entire complexity, that maybe Gherkin specs are not the perfect tool for the job. Maybe tomorrow some kind of other standard will emerge that will be much better than the combo of Gherkin and Cucumber. Another thing that I might want maybe my tool to help me with is generating tests from spec. For now, you saw it, monkeys completely ignored my plea for verifiable test generation and just did it by themselves. This is obviously unacceptable. I want my tests to be generated by a deterministic compiler and not by the monkeys. Is it something the tool can help me with? Of course. And again, it can be easily automatable if the intent integrity chain is realized as the structure of the progress of the process. Once I approve the specs, the tool itself can generate the tests for me. We don't need AI for that. So there are a lot, and obviously the biggest of them all, how to make guidelines really rules. I think it's a larger problem. It's not only intent integrity chain. I'm sure, Anton, that you would wish that the guidelines will be firmer and the AI will follow the rules more literally.
Well, like you want to see like a simple response by the tool, right? If you say that after a task is complete, make a commit, then it should do a commit. Like it's a simple rule or like a simple guideline, and you would expect the tool to follow that. But it's still probabilistic. Still doesn't do it every time. It might do it 10 times, and on the next run, it will not do that. Like,
Stupid monkeys, what can I say? It almost like what we want to do is having a set of two sets of files, guidelines and rules. And rules might even be, if we want to think about it, enforced by, again, the IDE, the tool, and be much harsher on the AI than guidelines, which are really guidelines and scribe kind of nice to have. So obviously, there is a lot of work to be done to make the intent integrity chain simpler to use, more deterministic, and more reliable. But I think the entire idea here that we have the very oh, what happened? Okay, that's the sorry, that's the demo from my from the doc. The entire idea here is that you never trust a monkey, and there is also always a verification of a step that is done by a monkey, either by human or by deterministic machine, is exactly what the future will bring us when we will learn how to tame the non-deterministic nature of AI with either human approvals or deterministic approval as well. And I'm not the only one who thinks that's the future. Andrei Karpathy said more than 2 years ago that the hottest new programming language is English. And while this is includes both vibe coding, completely unreliable and just trusting the monkeys when they should, and intent integrity chain, which is exactly the opposite of that. The whole idea that prompt is where we begin with, I think by now is indisputable. And in the end of the day, intent integrity chain is not about prompting. It's about the alignment between the prompt and the end result when it's done through the chain of the prompt, the spec, the test, and the code. So every abstraction leap starts with panic and ends with progress. This one feels a little bit different. The panic is more justifiable because we trust our future to non-deterministic monkeys, but I think we can find a way. Intent integrity chain is definitely a solution. It's a solution that works today, although it didn't work in our demo, but it definitely works. And mastery matters more than ever. In order for us to verify what stupid markings are doing, we have to understand what we are doing. And this is why whoever adapts will become even more critical to our industry than ever. And obviously, the idea that shared understanding, the stuff that humans write and read, is now executable in a verifiable way, this is absolutely critical. And with that, thank you very much. I'm at Baruch everywhere. If you also want to follow Leonid, and you should, he's at Leonid Golnik, and he is absolutely brilliant and a huge part of this of this presentation as well. We also used ChatGPT a lot. Can you hear it? No, probably
No,
can't.
no.
Yeah, okay, never mind. It actually says that it worked with us on this keynote and it was cool, which it was. And intent integrity chain, if you want to talk about it either in social media, use this hashtag. Let's see what other people think about it and if we can build any kind of conversation about it. Speaking.j Baruch is where the presentation, the video, and the working demo is, not this one. So you can go and scan this QR code. And with that, that's the end of my presentation and demo. And let's talk about stuff. So this is speaking.j Baruch. This is where you go. And here is the Back to the Future of Software. So if you click here, you will see the slides. They are clickable. You will see the demo. Uh, this is me.
We tried
Lots of
this one.
fun.
That
And
allows
then
us
here
to
is the demo. The integration explained plus demo code. It will take you to my GitHub, and it's an article that goes in detail to what we just spoke about. That would be the GitHub for the demo. It has the article about intent integrity chain, pretty much what we spoke about, but in a text format, and it's also shareable. So go ahead and use it. And this is the to-do project that I showed in the demo. And .Junie here has the guidelines, which is intent integrity chain rules. Here you go.
Mm-hmm. Cool. One thing I just thought, like currently, the way agent behaves, it takes your prompt, it takes the guidelines into account, and it tries hard to, let's say, generate a plan. Right? We see the Junie's plan right there, and it kind of tells us that it will follow the plan, but it might not follow it completely. It might skip some phases or ignore some of your requirements. So what I'm thinking is, what if the prompt that we submit together with the guidelines would actually generate the agent itself, so that the
Or,
stages
yep,
would be deterministic, and then
yes.
the actions would be actually the LLM actions.
The other way around, we can come up with a syntax that we can express the plans for Junie. And we can call it a marked like plan.md and put it in .junie folder, and it will have a structure that will become Junie's plan automatically without the scholastic nature of the plan generation at the moment.
Well, Markdown is cool, but it's a JetBrains product, then most likely it will be a Kotlin DSL.
Frankly, I think Kotlin DSL wins over Markdown any day. The reason why I mention Markdown is because the guidelines are in Markdown now.
Yeah. Right. That could be a cool outcome. Let's see how it turns
It's
out.
it would be absolutely amazing if we can express the plan like in a DSL, and it will be commands like stop, get input, and what's not. That would be brilliant for sure.
Perfect. Well, thanks for coming, Baruch. It was very interesting.
It's
I
my
think
pleasure.
I think folks are like very grateful to you for all this presentation. And folks, Jay Baruch is on our Discord as well. He is not
I
a
am.
hidden
I
person.
am just. I'm
He
just
is
logging in to say hi to everybody. That's exactly what I'm doing right now.
right. So to all the community, to all the folks who joined us today, thanks everybody for joining and asking questions and suggesting all kind of ideas for the live streams. Let's keep it up and suggest more. All right. Bye, everybody. Bye bye.
Bye bye.